Hi, this is Abdullah from Lattice Semiconductor, and I'm here to talk to you about always-on computing. I'm going to show two different use cases for always-on computing. First of all, I'm going to talk about always-on cameras. These cameras are capturing everyday behavior, and we want to look for certain behaviors and certain items. First of all, we want to look for human faces. Now, a lot of times where this is important is, for example, security cameras in your home. You want to be able to trigger whenever there's an unwanted person in the home when they're not supposed to be there. However, you don't want to trigger when there's a cat or a dog also in the same living room. So what we've developed is a human face detection. We're using a binarized neural network, and we're able to implement this on a very tiny 2mm by 2mm FPGA, and we're able to detect anytime there is a face. So whenever there is a face in the window, the green light will turn on, and it'll confirm that there is indeed a face. Now, this can detect anybody's face, not a very specific face. So we're not doing facial recognition, we're just doing human face detection. We've implemented the exact same solution two ways. One was the way I just showed you, and the second way is using a complete RTL solution. The only difference is that the first approach, we use the soft core RiSC-V processor. So you do all of your development in C. It's a little bit easier to do development. However, the power consumption is slightly higher. We're talking around 16 milliwatts for 5 frames per second. With a full RTL version of the same solution, we can do 5 frames per second again, but now we're going to consume 700 microwatts. And again, every time there's a face in the present, the LED light's going to turn on, detecting that there is indeed a human face present in the image. We're going to keep going on this always-on compute kind of functionality, and we're going to go on to these always-on cameras. Now, the difference there is the intelligence is all happening inside of the FPGA. The analytics, the neural networks, the detection mechanism, everything is happening in the FPGA. Here, all we are doing is we're capturing the images, processing these images, and sending the images to the cloud for the analytics and the intelligence to happen in the cloud. We're using Amazon Web Services, and we're able to do 3 types of detections here with 3 different cameras. These two are both pointed at this mug. The first one is trying to detect what is it looking at. And if you go here, you can actually see that it's 91% confident that it's looking at a cup. If you go to the next tab, it's going to say 98% confidence that the first word on that cup is the word life. So we're able to detect what is that object, we're able to detect what is that object displaying in terms of text. And this is all happening with cloud-based intelligence, where the FPGA is sitting locally, and again, we're doing just the image capturing through the image sensor, we're processing that image, we're sending that image to the cloud, and we're also providing the graphics acceleration to provide the image display back on the small LCD on the side of this box. So item detection with intelligence in the cloud, item detection or face detection with intelligence on chip. Those are the 2 different versions that I wanted to show. Now again, keep going with this always-on compute kind of functionality. We're going to talk about always-on displays. These displays are full graphics resolutions. You can see the difference. This one is drawing a bunch of lines or a bunch of squares very quickly. For example, we can do 557 squares a second. So it's very quick. And what we're doing here is we're showing that you can have very simple, low bandwidth data being uploaded into our FPGA. We're using Bluetooth technology. And that information can be converted to graphics commands, and we can drive these different displays. Each display needs a single FPGA. And the cool thing is it's the same FPGA that I was doing the face detection on, the same FPGA I was doing the Amazon Web Services analytics on, and it's the same FPGA doing the always-on graphics acceleration. Finally, I wanted to talk about another technology. Actually, it's a combination of 2 technologies using the same ICE40 Ultra Plus FPGA. And this one's using the face detection that I showed you earlier. And it's connecting that face detection output to a LoRa node. And this LoRa node is basically communicating up to multiple miles away, very low power, sending kilobits of data. And the data that it's sending is basically saying a yes or a no. Was there a face present or not? And the information gets sent to this gateway that we can present on any web server, and we can see how many people are walking in or walking out of a building or a house. And that way you can count and determine exactly when somebody is in a house, when they're supposed to be or when they're not supposed to be. So wrapping up, these are all always-on compute type solutions that we have available on ICE40 Ultra Plus. This is Abdullah. Thanks for spending some time with us here at Lattice.